Hello and welcome to the channel. I'm Suchlin Singh and today we're going to learn the language generated by a grammar and how do we find it and what all tips and tricks we require to do that. So let's come to the part what is grammar actually. So grammar, as you can see on the screen, grammar is depicted by four things, which is VN, sigma, P and S. VN stands for variables, sigma for terminals, P for production set and S for start symbols. So let's start with what is VN. VN will be the very first set. If this is a question which is provided to you, and you can see here it's written G, and we've got four different and distinct sets, and it is written find LG, which means find the language of the grammar provided. So on the very first separated by the very first comma, you can see, and before the very first comma you can see there is a set called S, and you can see this is actually the variables. Now this set may contain different things like S, A, C, B or other things. So anything which contain which this set contains will be from capital A to capital Z, and uh, anything which you find in capitals, assume it to be a state. Anything you find in small or numbers or special characters, consider them to be terminals, right? So let's come to what are terminals. Terminals are the things which actually exist as the input symbols. Supposedly 0 and 1. What 0 and 1, we might have 2 or 3 or something like that. So anything which is ranges from small a to small z, or 0 to 9, and all special characters come in terminals. Now what is production set? This is the most important part. This tells us actually where does our state leads to. So if it says S goes to 0 S1, so it will give an output as 0 S and 1. Okay, we'll talk about this later. And this says S goes to null. So S goes to null means that S will give an output null. Okay, so the last part, which is the start symbol. What is a start symbol? A start symbol is like we had in our the DFA or NDFA, we had something called Q naught. Usually, Q naught was the state which actually started our automata. So this arrow actually pointed out that which automata is actually which state is actually starting the automata. This acted as an on off switch. So this is the same purpose of this S symbol right here. Okay, so before starting to solve the question, let's provide you with some tricks, right? For solving these, you need to understand what actually this means right now. So if 0 S1 is written, so S goes to 0 S1. So we'll have the start symbol as S, so you need to put the S right here. Then you'll read all of these. So S goes to 0, S and 1, or S will go to null. So the trick one is that you need to find out the shortest string possible, and in this case it is null. So when the shortest case possible is null, so null means nothing, and that is it. So null, like just keep this in mind. We'll probably come back to this null, that why this is important. This will be important like when we'll be providing the number n. We'll be talking about it very soon. Okay, so let's see if we just use the first part, which is this. So if we use this, we get 0, S and 1, and now we just need to replace this S by a null. So we get 0, null, 1, which will give us 0 and 1. So this is our shortest possible string without the element null. So you cannot take null as the shortest element, but yes, we need to consider it, and we'll come back to it shortly. So 0 and 1 is something which will be getting, which is possibly accepted, right? So 0 1 is the shortest possible string possible, or the shortest possible string, and then you'll find out a pattern. You can substitute this with different parts. So let's start. What we're going to do is, what you can actually do is make a tree or something like that, but what I prefer is that choose this S goes from 0 S1. Now I already know that S goes to null. So my shortest possible string will replace this as null. So I'll get 0 and 1. And I also know that S goes to null also is existing. So I have to consider it. So I'll just write it and draw a box so that whenever I just come back to the question to review it, I know that there is something as null present, right? Let's come to the next part, which is making a pattern. So next trick is make a pattern. These things will actually make it easier for yourself. So you get it as 0, S and 1. Now you want to replace this uh, with two things, which is 0, S and 1 or null. So we've already done null, so we'll just go with another one, which is 0. And now let's just color code this thing as S. So I'll just replace this as 0, S, 1, and the old one exactly present here. This is the next step. So let's just number the steps. Okay, this is step 1, this is step 2. And now if you just replace this S with null, you'll get just draw this 0, 1 and 0, null, 1. So this will be providing you with 0, 1, 1, 1, right? So this is what you get after just choosing null. So you don't want to choose null, what you'll be doing, you'll be choosing this 0, S, 1. We already have 0 and 0, 1, and now you'll be replacing this S with 0, S1, so you'll get 0, S1. Now with after 3 iterations, so you got the third iteration here. Now actually replace this with null. So you get 0, 0, 0, 1, 1, 1. This is your final string. Let's just write this as final string. This looks easy and this looks nice. So now what we administer as a pattern is that we got 0, 1, then we got 0, 0, 1, 1, we got 0, 0, 0, and 1, 1, 1. So we see that ones and zeros are actually increasing in the number of iterations we are actually having. So if you watch very carefully, this was the first iteration, this was the second iteration, and this was the third iteration. So now if I just try to write this in a bit more mathematical way, I can actually write this as 0 to the n and 1 to the n, right? Where n is greater than equal to 1. Now this is the place where I would consider the null which was present. Now why do we consider null? Since s could go to null, and null is a terminal because we have said that all special characters are terminals. So what we need to do is, if we just take this as null, it will be nothing. So 0 to the 0, 1 to the 0 will provide us null. So now this n can be changed to 0, and this is why we need to consider null. Because if we hadn't considered null, the lowest possible string would be 0, 1. It is not so, it is null. So the answer will be LG 0 to the n, 1 to the n. Now you can use two symbols here, which is for every n greater than equal to 0, or just use a slash sign or a standing a symbol which is directly under your backspace key. So you can copy that and then you can print that. So let's come to the next part or the next question. Just let me scroll down quickly and find out a good question, right? So we've got another question which says G is equals to, yeah, this one's interesting, S C. So now you see here there are two capital letters. So these are our states A and B. So instead of 0, 1, we'll be using A and B. This is so simple. We've got P and S. That should be S. And this is our closed bracket. So now here we want that, now it states differently here that P consists of S belongs to A, C, A, and C belongs to A, C, A, or B. Now, this is somewhat, you can say, of an easier kind. Now, so you see, S and C are the two states, A and B are your terminals. This is your production set, and you already have a start symbol colored in the same color. So you see, you'll start with ACA. This is the minimum thing you'll get. So now we know that B is a terminal, but we cannot start with B because this is S, and it clearly says you need to start with symbol S. So we need to start with S, and then we can choose whatever we want. So I'll start with S, which says you can go to ACA. So this tells me to go to ACA, and now S doesn't goes to itself. So actually both of these are same, so it doesn't matter. So I need to check A. So uh, I need to check C. Sorry, so I need to check C, and C says that you can go to ACA. So I'll just write this very quickly for you. Okay, so what is the part which we do? Which is the first trick actually, which is up our sleeve, is find the shortest possible string. So I'll just write it again here. Shortest possible string, which is this ABA. Because we start with S, we get this. The nearest terminal which we got is B. Place it right here. It's done. Okay, so this is our first iteration, and we got AAACA, and let's just use this C and go to ACA. So you got to place this A, and then another set of A's, and then place the ACA. So second iteration. I think this is enough for this part. And then you need to do is this. You get all the A's part, and you just replace this by B. So we'll just do it very quickly. Get all the A's right, and now what is left? B. So here you see something. We've got A B A A A B A A. If you just place B right here instead of going here, you just go here. So you get A B A A. And now what we see is a pattern with similar number of A's and B in between. So A B A. Let's just try to write this in a more mathematical form. As you already know, we can write LG as A B A, and for every n greater than equal to 1. Now what is missing? The powers. Now before writing this n, I'll just explain why we wrote n, because the A's come exactly in the similar amount on the LHS. Let's just point out this is our LHS, this is my RHS, and they come in exactly same numbers. For our iteration 0, we got this is our iteration 0, we got 1A. For our iteration 1, we got 2 A's, and for our iteration 3, we got 3 A's, and B exactly comes once because there is no other thing calling B without you can say without actually B is just a terminal without actually calling a state. So B will just come once. So we get this as our answer. It's totally right. And this time we see that there is the shortest string possible is ABA. So if you just replace this n by 1 actually. So this is method that this is actually trick 3. So if you are actually confused that is this the right answer or not, you just need to do is this says n is greater than equal to 1, which means that the minimum possible value for n is 1. Just place n right exactly here. So we get A. Let's just use the colors. Just becomes more interesting, and replace n as 1. So what you get is our shortest string, and this is what we got right here. So this you can use is verifying that is your answer correct or not. We're just reverse engineering the process. So we've got this answer. So let's just go on and do a small other example, shall we? Okay, so sometimes the question might say that if G is S belongs to AS, BS, okay, so we can just write this as S belongs to A and B belongs to A. Find out. Okay. Oh, doesn't say that. My mistake. It says S belongs to B. Find out what is actually happening. Right. So this is the most easiest part. What we need to do is we can see that as we have only two terminals, so we can have either A or B, but S actually starts with both of them. So all of them actually. So we have the shortest part as A or B, right? This is actually an important case. Let's just write important here. You can see we can just terminate the string by using A or B, or we can use A, S and B, S, and then we can go on making A, B, B, S or B, A, S. Now let's just give all of them a color. It'll be easier to identify. And let's find a more suitable color for them. Right. So if you use just B, we've got it here. If you use just A, we've got it here. And if we just use BS, so just got it here. And now what I do is I already have this B and I substitute it like this. Or I can substitute this BS like this. This BS will actually be replaced by AS. So now if you see here, this will provide you all the strings that can be made up by using A and B. So what you'll be writing right here is LG belongs to A, comma B, closure minus null, and this will be equal to A, comma B, right? So this is not this, right? So let's go and solve another question. I think I have one more for us in our bags. Let's see, this one is gonna be a bit difficult for you. That's not difficult, that's just a bit more challenging. So we've got S as A and S C, A as A B, or that's A B. So now we need to start with these. We've got S as A or S C. So let's just write A here and S C right here. Okay. And then what we can do is get to the, like, this is like the guideline you need to follow is like find out the smallest or the minimum possible string. So we'll terminate it as fast as we can. So I got AB right here because I used, okay, so let's just provide them with colors. This is A, this is SC, this is AB. Okay, so we need to have some vibrant colors, and this is my, so I got A right here. I actually used another state for it, right? And now I've got SC right here, and I want SC to be replaced by something, and it should terminate it as soon as I want. So I've got something which will be terminating it. It is my AB. So I got AB right here, and C which came from the previous state. So ABC and AB, these are the shortest possible strings, both of them, cause S can go either ways, so we need to consider them both. Coming to the next part, what we can do is for A can also go to A, B, and then A can again go to AB, which will be like A, B, and these, right? Or it can go to A, B, and then it can again go forward. So this is probably our third now. This is our second iteration. So I think that's it, and we don't need to go any further. We'll just get it as like this. But the thing is that we get a C in the end every time, like because we start with C. And now what you can do is you can get it as A C if you just use this part, right? And S actually calls for SC. So S starts with SC, right? And it doesn't call for A right here. So S can call for A or can go for SC. So you can then actually let me explain. This C is already present here. So one more C will be added, and next time it calls for SC. This C will be already present. This C will be already present, and another SC is added. So every time an SC calls for itself, a new C will be added. Okay, and here we can see that there are same numbers of A's and B's. So let's just put this into more mathematical form. Let's just keep it right here. I can write this as LG equals to A to the N, B to the N, and C to the M for every N belongs to 1 and M not belongs to N is greater than 1 and M is greater than equal to 0. Yeah, there is the greater than equal to sign, right? So now why have I chosen these as different? Because here if you see, if I just go for SA, and here I do not have any C. So if you do not have any C, where does the C go? So as we know, anything to the power 0 is 1, and which if is concatenated with anything, like if I just concatenate A into 1, what I get is A. So I don't really care about that. If it goes to 0, it will just give out these two strings. So this is the answer. I think try to make it very clear that you just need to follow some easy steps, which are find out the minimum or shortest possible string, then find out a pattern, and finally if you need to check, place these here, and you'll get, if you get the shortest possible string, it is working quite well. Thank you so much and keep practicing.